Now, question number 15. So, a continuous belt of which 0.6 meters travels at a constant speed of 2.5 meters per second. The belt has a uniform distribution of charge of 5.0 millicoulomb per meter squared on its surface. Now, this 5.0 millicoulomb per meter squared is what we term as the charge density. Now, as the belt passes a point, all the charge is removed and is carried as current in the wire. The question wants us to find the current in the wire. This is a very interesting solution. So let's jump now straight into the solution. Now, first of all, you have to know what is current. So current is a quantity of charge that passes through a particular section of a conductor or a material in a given time. Okay, but if we are looking at this question, we can define current as a quantity of charge that get collected through the wire per unit time. So we can write mathematically that I is given as Q over T. You realize I talked about charge density. So charge density is the charge distribution per unit area. And the question is given us that to be 5.0 millicoulomb per meter squared. That is charge over every 1 meter square area of the belt. Okay, now let's do an estimation. So we want to do an estimation and we are taking just 1 meter of the belt. So for every 1 meter of the belt, we want to find the area there. And we can then extrapolate or extend it to find the charges on that particular area, which is what we want to calculate for. So we picking 1 meter length of the belt with an equivalent width of 0.6 as we are given in the question should give us an area of the belt to be 0.6 meters squared. Okay, now let's do an estimation and find the number of charges that we can find for that. So picking 1 meter, that is the length of the belt, we can say that the quantity of charge that can be deposited or that is found on that 1 meter of the belt is given as 0.6 meters squared divided by 1 meter squared, because that is per every meter squared. So we are looking at 0.6 of that meter squared times 5.0 times 10 to the power 3 coulombs. Mind you, this is supposed to be 10 to the power minus 3 coulomb because it is milli, so minus 3 coulomb. So when we simplify this, we should get our answer here to be 3.0 times 10 to the power minus 3 coulomb of every meter, or lambda, which is standing for the charge on a particular length of a conductor or a material, is given as 3.0 times 10 to the power minus 3 coulomb per meter. Now, once we found that once we pick a 1 meter length of the belt, the charge that is deposited on the belt based on the charge density we are given in the question is 3.0 times 10 to the power minus 3 coulomb. We can extend and now find the total charges that are there. Okay, and once you know the total charges that are there, we can find the current that is collected into the wire. Now we are told that the speed of the belt is 2.5 meters per second, and that speed is constant. So another way we can talk about is that the belt travels at 2.5 meters every second. 2.5 meters every second. Now, if 1 meter of the wire has a total charge on it to be 3.0 times 10 to the power minus 3 coulombs, how many charges, or what's the quantity of charge that will be present when the belt travels for 2.5 meters? So that is the quantity of charge on 1 meter multiplied by 2.5, and that should give us 7.5 times 10 to the power minus 3 divided by 1 second, and that should give us 7.5 milliampere. Mind you, the unit we are getting here is coulomb per second. Coulomb per second is the same as ampere. Okay, so let's switch back to the question and see which one is our answer. We've already found it here, so let's see if our answer is in the possible answers we are given. So from A, B, C, and D, we realize that our correct answer here is B. B is our correct answer here. All right, so see you in the next video.